This is, I suppose, a picture of the same scenario, just showing it in a real-life type of situation. So that same sort of nasty pattern, and remember, this nastiness varies with frequency. Now you can see that you've both got a problem in terms of talking in all directions. In other words, depending on which way this car is pointing, you may have radiation going that direction, you may not. But even worse, if you look at the elevation, you could have much of the radiation going upwards, for example, or downwards. In both directions, not useful for your communication. But people will quote you these things here as the gain of the antenna. And of course, because it varies with frequencies, that point there that currently is at this frequency, the peak for that specific antenna could be at that. And once again, nonsense. You need to know what's happening in the direction you're going to use it for. So of course, this would be the ideal case, where it is actually omnidirectional and all sides. Never possible with the actual vehicle. The vehicle will change it, but you want it as good as you can get it. And of course, where the maximum is towards the horizon, not towards Mars, Pluto, or the Moon. Okay, that covers sort of, I think, the most important parts. In other words, gain varying with frequency, pattern varying with frequency, and gain being defined in this foggy fashion, which can almost make people print anything they want on a spec sheet. If we look at polarization, polarization has got to do with the direction in which the E-field vector varies. Because we all know that the radio wave is actually an electromagnetic wave. It's got an electric field and a magnetic field. It's the finest direction of the magnetic field. It's also normally, if you can see elements or it's a vertical like this, normally in the direction of the longest part of the antenna. This would be horizontal, that would be vertical. The most important part about it is to know that if you're talking horizontal, you have to have a horizontally polarized antenna at the other side. If you try to talk horizontal to vertical, you virtually get no signal. Okay, so it's very important to have aligned polarization. This is a circularly polarized antenna, the helical that we use in tunnels. Very good for propagation underground because there's a lot of reflections. Where the vector rotates, it's quite useful if you don't know what is the direction of your receiver, for example, a mobile or handheld. But you pay a price of you lose half the power if you take linear to circular. So those give you polarization. In a sense, nothing to do with the pattern. It's a separate characteristic of the radio wave. The most interesting one is, of course, now for MiMo, the most successful way of getting two decorrelated signals, in other words, having two antennas in one enclosure and getting your full, say, 2x2 doubling of speed, is to transmit one horizontal and one vertical. It doesn't matter if it's horizontal and vertical. It could be plus or minus 45. And just for interest, even if the base station uses plus or minus 45 and use 0 and 90, MiMo electronics will actually sort it out. You'll still get your full decorrelation and the doubling of data rates that you would expect.